Hello, this is Charles Demler. This is Basics to Project Charles, Part 2. Now, another thing about the hurricane, this brown line represents the structure. The blue represents the winds. Okay, the pink or whatever represents the winds of a hurricane that is actually going on. Now, if you put the structure within the winds of the hurricane and you have it going, the winds that go around the structure would then be going around like this. Now, what happens with hurricanes, if there's two eye walls in the same place, what they do is they wrap around. So what's going to happen is we're going to continue with the winds around the structure going like this, and what we're going to create is the winds going around the hurricane going like that. And that's what will happen in nature. And what we're actually doing then is we're pulling the hurricane, the eye wall of the hurricane, we're basically pulling it over towards the structure, to on top of the structure. And that's basically how we're moving a hurricane from like the Gulf of Mexico to the middle of the Atlantic, is we pull it south of Florida and just off into the Atlantic. Change the course that the hurricane wants to go by 3 to 30 miles per hour. So if, let's say the hurricane is going in one direction and you got the structure sitting right there going along with it, it's going to pull this hurricane off in this direction by 3 to 30 miles per hour, depending on who you ask. Once it gets to Category 5, it will be able to be pulled faster than the Category 3, which you can pull faster than a tropical storm. Tropical storm will just get pushed wherever the weather systems around decide to push it. And with the clouds, one of the tricks is to drain it over the ocean of the excess moisture that you do not want hitting land. So let's say you drag it down the coast of California. Then you don't want all of the clouds to go and flood out the west coast of California. You want to drain the water out of the clouds, and you could drain it into channels out in the ocean that would connect to land, where you could have fresh water then for reservoirs, depending on how far away from the hurricane you drained it. So you'd want the hurricane like 100 to 200 miles offshore as it went down the coast, so where it'd have fresh water that you'd collect for the reservoirs. And you could also have this thing over a reservoir or a waterway that led to a reservoir. Just have the structure drain into a waterway that leads to a reservoir. Now the placement of the hurricanes, if you place one over here, it will make it rain over Africa, which could then go into a waterway, and then you could have it rain and provide water for drinking and irrigation all over Africa, or South America, or the west coast of the United States. And the second benefit of doing that is you drain the clouds so that they don't have enough moisture to create tornadoes.
We're going to stick around with most of these clouds as we go throughout the night.
And when I talk about my waterway, I'm talking about something that has the inside where the water is rubbing up against. There are ways to make that as smooth as glass, so that when the water goes around here, it's not having any friction. So it acts as a big battery. You could have it pass by a power plant and then speed up the water in the waterway. And then over here, have a site where you need power, and then you generate power, which would be causing the waterway to slow down, depending on the power that you're generating. Just got to get the efficiency up, but it's a great way to transfer water, energy, cargo, and power all up and down the coast of California. And you just have to have the places where you collect power, different areas. Which gets into my next thing, which is taking the sun's energy, then collecting solar in it. You can apply that energy towards speeding up the waterway, or if there's a lot of energy that you don't need for speeding up the waterway, you could beam it out into space. We've got solar that takes up, new solar that's able to take up all of the different spectrum of the rays from the sun. And there's articles that I'll get into in the next sections that talk about how they're able to collect 60% of the sun's energy. So if you collect 60% of the sun's energy and then beam that out into space, you're cooling down the planet. You're cooling down it mostly localized. For it to have a planet-wide effect, you'd have to cover the entire deserts, which isn't something that I'm saying that we should do. But this would be great for the desert out in California, Las Vegas, Arizona. And when it's not at the temperatures that we'd want or need to cool down the cities with, it would be used for industry. But just think, if you could have Vegas at 120 degrees, or if you could have it at 100 degrees, or even just a 10 degrees difference from 120 to 110. That's the differences that I'm talking about. It's not going to, it's not going to get much more than that, if that. So we're not talking about a major solution, but it's something to think about. And if that same thing can power industry and power houses, that'd be a great thing. And, here's another view of the structure, the main hurricane control structure, and it would have stuff that would turbocharge the thing, such as a steel processing plant, sort of like a 20-mile diameter structure, and would grow seaweed and other stuff in there. A nursery, so you could plant it all over the oceans to provide food, enough, to feed like 20 billion on the planet, possibly. The most important thing is to make it so the food feeds the people that are otherwise destroying the earth. Anyhow, that's the basics.